Hello everyone, my name is Gemma Rodriguez and today I'm going to present a recent empirical software engineering paper, How Bugs Are Born. This is a collaborative work with the great professors Gregorio Robles, Jesus Maria González Barahona, Alexander Serebrennik, Andy Seidman, and Daniel Herman. Due to time constraints, I will give you a brief overview of the paper, but I encourage you to read it and ask me any questions you might have. So in this paper, we study how bugs are introduced based on information available in the software repositories. Here, it's important to mention that we only focus on bugs. We don't focus on new features or new requests or other kind of issues. Particularly, we have proposed a theoretical model with a specific criteria for deciding if some change introduced the bug. This criteria is, did the change cause a bug when it was included in the source code? Finally, we operationalize the proposed model and empirically evaluate it into open source software. With this criteria that I just mentioned, we try to decide if a change really introduced a bug when it was written or if the change was maybe right at that time and it was later changed due to specific changes in the specifications or external APIs. This criteria leads to the concept of extrinsic and intrinsic bugs. And this is important because while intrinsic bugs are originated within the software, extrinsic bugs are originated because of changes in the environment where the software is created or run. So here we have an example. If we have the commit history of all changes done in the project, an intrinsic bug is when starting from the bug fixing commit backwards, we can identify a specific change that caused the bug when it was written. However, the extrinsic bugs don't have a specific change recorded in the control version system. So if we start from the bug fixing commit and we go backwards, we cannot identify a change that wrote buggy lines at the time of being committed. More clear example might be this one. Here we have a project that uses the NumPy library. We can see that there is a bug that has been fixed. So to identify whether the origin was intrinsic or extrinsic, we need to use our criteria to understand whether the change that introduced the code modified in the bug fixing commit introduced the bug at this point of time. We are talking about this change. We have to apply our criteria to this change. So after applying the criteria, we can observe that this bug is intrinsic because this change was using incorrectly the NumPy library. However, in this case, the bug is extrinsic because the change was using correctly the library at that time. But then NumPy changed the API and it causes that the project exhibits the bug. So our theoretical model asserts some assumptions which are needed for the definitions and methodology proposed. But these assumptions are very close to what practical real system shows. For example, we assume that projects have a control version system. Another key concept we introduce is the perfect test for a bug. Intuitively, it's like a regression test designed to test for a bug, but it's perfect in the sense that if applied to a change on the source code, it will fail if and only if the bug is present. So to evaluate our proposed theoretical model, we operationalize it and then apply it to two open source projects to identify the origin of 116 bugs. This process helps us to create a manually curated dataset that we then use to evaluate how well four current algorithms perform when identifying the origin of bugs. So our results indicate that the criteria defined in the model enable us to classify bugs as intrinsic or extrinsic, and also to create manually created datasets that contains information about intrinsic and extrinsic bugs. Also, for the 116 bugs analyzed, we found that 9 to 21% of the bugs were extrinsic, meaning that they don't have a bug intrusion change. And this is very important. Finally, we found that the best algorithm actually only correct for 61 to 63% of the changes identified as the origin of the bug. So the takeaway here is like, first, there are intrinsic and extrinsic bugs. Thus, we cannot assume that the lines changed to fix a bug are the lines who introduce the bug, so are the buggy lines. And this is very important because these results have many implications in software engineering. As many previous studies, software tools and review practices assumes that all bugs are of intrinsic nature. With all of this, thank you very much for listening to this presentation. Bye.